Hi everyone, and this is Sarath, and I'm working as a cybersecurity engineer. And I'm interested in machine learning like everyone, as it is a buzz in everywhere nowadays. So today I'm trying to make a video on basics of machine learning, means basic building of a machine learning, you can say, where I'm trying to build a neuron, uh, and I'm trying to use that neuron. Like I will explain I'm trying to understand the concept and which I understood. I'm trying to put it in explanation, and then I'm trying to implement that in a Rust code. As generally, like we have any code we can implement, but I'm interested to develop that neuron in Rust, and most of the people have already developed it, and I'm also trying to, as in interest, I'm trying to develop that, and I'm trying to explain that what I have understood from my perspective how the neuron works and that thing. So, and this is a part like I'm planning to make multiple videos on machine learning, and this is a part of means it is a first video there on machine learning basic. Like here in this part I'm planning to make this part like a neuron, basic neuron. This is like a direct application of a neuron into an in a data, with the data how it will work. And next video I'll make on how to train a neuron with data. This in this video I'm not covering the training the neuron. Just here I'm trying to cover like how a neuron works if we give some data to that, and how we'll build a neuron with using Rust code. The training, how we'll train a neuron, that we'll see in a next video I'm going to make. And this will the first part, how we'll use a neuron in a code. This is a single neuron, and that can be multiple multiplied or extended to multiple neurons if you have in a model. So let's directly let's check initially like what is a neuron like. So 1 second there. Mm, okay. So basically this is the neuron. So I'm trying to this is the like architecture of a single neuron, and in this we have three inputs: x1, x2, x3, n inputs actually. So corresponding that there are w1, w2, w3 weights, and there will be a bias. So we'll talk about this bias, how we are going to use help that bias, how that bias will help, and then we'll all these things will become across one activation function, which will do the summation of all these things, and there will be a sigmoid function, and then there will be a output. So there are means activation function, how it will work, and also there is a sigmoid function how it will work, how to implement that sigmoid function, and, how the output will comes. All these things we're going to see in the this is the architecture, and how we'll turn this architecture into a program, and in a program how it work we'll see. So I have a simple code. I will try to explain that code how a neuron works. So here I'm going to explain you very fast here. So basically, as we are trying to build a neuron, So here I'm saying this is the neuron structure where the neuron basically a neuron will have weights and biases. Weights, how many weights we can have in a neuron? As per my understanding here, what I'm observing is number of inputs we have. Based on that number of weights we have to take. That can be here the number of weights we can define in a vector. So the vector will have a number of values. So those values are defined from the number of inputs we have. And also bias will be single. What is the use of bias? We are trying to figure it out in later comes part coming parts. Okay. And basically here, this is the function which will initialize the neuron. So what is the initialization means? So here I said before, I'm not talking here about how a neuron can be trained. Means how the process of training I'm not explaining. But here what we are trying to do is uh, directly here we are taking one neuron and that is not we're not putting any values into that. We're putting zero values which is not trained. The neuron is not trained. So we're pushing some values. Means all weights we're pushing as zeros here. The training part we are not doing here. Means if there is a model in the sense if we have trained some neuron, then we can take that trained data and put it in here. We can in this part we can put it as a training, like the trained data we can put here. So then we can decide what data we are just trying to distinguish whether it is comes into whether the input data is comes into input data is activating the neuron or deactivating the neuron. That thing we can decide. But here we exactly I mean so I'm also not sure like how the input uh, here, but here I'm like behavior, but here I'm trying to explain how a neuron works when you give an input. It's the calculation part I'm trying to explain here. So so here we're trying to put all the weights into 0 0. The size of that weights, how many weights will have in a neuron are defined by the number of inputs we have. So here we have three inputs. So the size of this neuron, weights in the neuron is same. Three inputs, so input size, the size of the weights is also three. So then bias is we're putting at 0 0. So we'll talk about this bias in the next. Then we are initializing the neuron. Then what is the function or use of this? What is the functionality of the activation function is? The activation function is the function which will, when you give an input, which will try to calculate the neuron's output. So what we are doing here, for example, we take here. So these are the inputs, and the weights will comes from the training, and then we have to calculate the sum of the input and weights and bias will give the which are calculated by the activation function. That summation means multiplication and summation of that those values are calculated by an activation function. So that thing we are doing here. Here we this is the thing which is done all this multiplication, summation, and addition, and figuring out the overall sum of weights. And then when the sum of weights comes out, like the output of an activation function formula, and then we are adding the bias to that. And after that means whatever the output we get here is in the range of whatever the output we get here, it is in the range of minus infinity to plus infinity, and it is entirely depend on the type of data we trained and type of input we given. So it will be in the range. So if we want to map that data in between 0 to 1, Then we have to go with this sigmoid function. This is, you can see the value, maximum value and minimum value. It is the like um, it is the exponent. The sigmoid function is like exponent of e power like 1 by 1 plus e power lambda. This value will be always that this value will be always more than 1. So the range of this entire formula will be in between 0 to 1. So that based on that we can decide, means whatever the values we'll put, that will comes around 0 to 1. So based on the, we can put a probability based on that, means which probability will take it as a activated and which probability will take it as a not activated. That can, we can decide based on the output of the sigmoid function. So that is the entire neuron this thing. And now if you go into this, so here we are creating a input, giving input like 0 minus 1, all these things. And then here, this is the function we are initializing, which is like if you have a trained data or weights, then we can directly put like when they calling this new, that time we can put that weights into this weights, like the trained weights we can put into this weights, so that we can completely distinguish the inputs we are giving, or we'll get a clear output whether it is activated or not, we can get. So as it is basic, I'm also new, so just I'm explaining that part. So I'll come up with in detail in coming. So I hope that you are understanding what I'm trying to explain here. So basically, as I mentioned before, I'm not talking about how a neuron is trained. I'm thinking that the neuron is already trained, and the training is like not done, and the values of the weights are 0 0. So no training is done on this. So, but I'm using the inputs and trying to figure it out the outputs. Obviously, I know that the output will be random. We cannot associate any specific meaning to the output, but still we're trying to figure it out how it's working. Working, we are trying to figure out, not we're giving any values to the output whatever it's giving. Okay. So here, so once we put the initialization, then we are trying to put the input and trying to calculate the output. How that inputs giving what, whether they're um, what do you call, whether they are activating the neuron or not. So so once we give the input, then we are taking the output, which will tell that whether the neuron is activated or not. So now let's cargo run will do. So so the output is 0 0 as we are giving minus. So there is no like here we cannot say whether the, based on the how we'll define means this 0.5 is, we can take it as a mm, activated or not based on our input. Like if there is a some specific use case where 0 0.5 can be considered as, means like we can put it probability of 20 80 30 70 70%. If the output is more than 70%, we can consider it as activated, and less than 30% we can consider it as a um, not activated, the neuron not activated. Means depend on the application and the data and the use case and the outputs the model is, the neuron is giving, we can define that. So that is the thing. And let's try to change some values, like I'm just basically I'm trying to manipulate the trained values here. So actually I come up with a clear thing how will train these values. For now I'm just putting some random values to the weights. I hope you understand this. So let's, So here I'm getting 0 0 means this value is deactivating the neuron. If you try to change the value to 1 and run it, and this value is activating the neuron. So one value is deactivating, another value is activating. So similarly, this is thing, and basically what we covered here is first thing is like how a neuron works and what are the things involved in a neuron, how we'll build, what are the important concepts of a neuron, that weights and biases, all these things. And the thing we are not covered is how we'll train this neuron. Basically, how we'll weights means based on the training data, how we'll create that weights. That we will I'm going to come up with the next video, and so that's it. Thank you everyone for this time of your wonderful time. Thank you.